Hey everybody, this is Larry. This is day 10 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. The longest increasing path in the matrix. We're given M and N, return the longest increasing path in the matrix. Okay? So yeah, I usually solve these live, so it's a little bit slow. Fast forward or skip ahead or watch another video. It's up to you. Okay. Yeah. For each cell, you can move up, down, left, right. You cannot move diagonal or upside. Okay. So n on the number of cells in this case is 200 square. Um, so you can do this in a couple of ways. I'm going to do it recursively. The key thing to know for this problem is that this matrix is going to be a DAG. And because this is strictly increasing, and because this is strictly increasing, that means that because it's strictly increasing, that means that there's no cycles, and yeah, and because there's no cycles, then you can just do it recursively by and caching it because it is the longest path in the DAG, and that is basically the standard way of doing it. Is just doing dynamic programming. Yeah, I don't know if I have a better way of explaining it, but basically, the question you ask and the question you ask is very important in dynamic programming in general. In this case, it's a little bit straightforward, and it is that for each cell, what is the longest path beginning at this cell, and then the answer is going to be the max over all the cells. So sorry if I'm talking a little bit awkwardly. I have the sniffles, so like my I have some congestion, so I can't really talk that well. But yeah, I think that's pretty much it. With most dynamic programming, one is recognition, and then two is just trying to figure out how to, um, how to get in a good place. And here we can and go just like start by well, let's go. Rows is equal to length of matrix. Columns is equal to length of matrix of 0. Okay, so we don't have to worry about dumping zeros. And then we just go longest of x, y, say, and yeah. And then we can just literally start with best is equal to 0. We return best at the end because that's the thing. We also want to construct. I'm doing this in a weird order, of course. It's just whatever comes to my mind because it is in what do we call it? This is live. Man, I am not very super well today, but you can hear me being a little bit not coordinated, and I apologize for that. But yeah, and then now we just go through each of the 4 directions, and then making sure that it is in an increasing kind of way. So I have 4 dx dy in directions. I usually do like the next nx and y is equal to x plus dx, y plus dy, and this is very standard grid looking grid graph-y stuff. That's how I usually write it, but you can write it however you like, and we make sure that it is in bounds. So this is for rows and this is for columns, and then once we do that, then we know that we can do this. We make sure that this is strictly less than nx and y. And if this is the case, then best is equal to the max of best or the longest of nx and y. One thing to note is that in a lot of cases, with backtracking or exhaustive search or something like that, you have to do some sort of like making sure that you don't go in cycles and then go back or revisit the same cells. In this case, the reason why you don't have to do that is because there are no cycles. So then we just ask ourselves, this question recursively of, okay, this is the case. Oh, oops, I messed up. Wow, this is +1. Because this is okay. What is the longest path at a given cell? Well, the longest path starting from this given cell is just equal to the longest path of its neighbor, assuming that it is it is going in an increasing order, plus 1, right? So that's basically the idea here. And this is roughly like 95% of the code. We can, and then as we said, we'll just max over all the x and y, possible x, y. So let's just do starting x in range of rows, starting y in range of columns. Let's also call it best. Is equal to max of best, longest, and then we return best. This is roughly right. I mean, I know it's not because I didn't do the memorization part. Don't worry. I know that I forgot this time. Oh, I didn't forget, but I didn't want. I'm not doing that quite yet. But that's one of the cases. It should still be fast enough, but we'll beat it up with a better case. Oh, I guess this is this plus 1 because you have to count the starting cell, which I forgot. Okay, so this will look good, but it's going to give us timeout time limited exceeded because there's just a 200 times 200 is going to be very slow, and we can kind of play around with that for a second. Hang on. Yeah, let's just say we have a big array, and this actually may be fast enough because it's actually a whatever graph, but I'm too lazy to really construct a case from scratch, so you might have to take my word for it. Yeah, so this actually happens to be fast enough because, like I said, the graph, like it terminates really early. But you could imagine a case where, and I'm too lazy to type this up, but you can imagine a case where it's like 1, 2, something like this. And then so forth, right? And then if you just construct that, then you're going to recognize that this is like Pascal triangle or binomial sequence or whatever. And from that, you know that this is going to be exponential. So this is going to run in exponential time, which is not what you want, assuming that you keep it strictly increasing and stuff like that. And this kind of test case comes up a lot in similar problems, so it's why I keep it in my mind. And and as you recall from Fibonacci, not from binomial numbers, it does grow really quickly exponentially. So this is a no-go. We want to cache. So yeah, if you have to here, then the thing that you can do is just realize that okay, the longest path on x and y will always be the same after you calculate it, right? Like you only need to do it once. With that observation, like because every input x and y is always going to give you the same answer every time, and that's the key part of memorization or dynamic programming. And because it does, then all you have to do is just want to save it so that you don't do it more than once, and then we can do that very easily by just having let's just call it cache. Let's go to I don't know -1. It doesn't really matter. Control for and then has cache and I just like writing this out explicitly for education purposes. And if you're at home, if you're still a little bit fuzzy about dynamic programming, I know that there are a couple of hacks, especially in Python, so that you can do this much quicker and easier. But I really urge you to kind of write out these arrays and matrices so that you can understand the both the complexity and analysis and also talking about it. And also, in an interview, people will probably ask you about it. And it becomes more intuitive once you realize that. But yeah, so here, so if as cache of xy, we return cache of xy. Otherwise, at the very end, we set as cache xy is equal to true, cache xy is equal to best. Okay, so this looks good. It's slightly faster, but you can't really tell. Usually I do an example about it, but yeah, let's give it a submit. Hopefully it's right. Cool. Yeah, so this looks good. So what's the complexity here, right? The complexity is, and this is why I have these things, is it makes it easier to kind of analyze. And I would also say that, to be honest, before you even program it, you should be able to think about the complexity, because otherwise you're not really solving problem. You're just guessing the solution, right? Which sometimes is okay for a contest or something like that. But obviously on an interview, you have to be able to explain it. So, guessing is fine, but you still have to be able to explain it. But yeah, but here X obviously goes from 0 to rows, Y goes from 0 to columns. So therefore, that's the number of inputs. The total number of inputs is equal to O of, let's call it R times C, which is, let's just call it R for now and C for now. Yeah. And then for each one, for each possible input, each input takes O of 4 work, which is obviously O of 1, because this direction thing only has, has only 4 entry. And I guess I didn't explain this part because I take it for granted, which is that this is just, up, down, left, right in some way for the dx dy. But yeah, so total time complexity is O of R times C, which is linear in the size of the input. And of course, for space, we just look at the total number of inputs, and because we also take O of 1 space for each input, this is also going to be O of R times C, which is, again, linear in the size of the input, because the input is R times C, right? And you can kind of obviously also see this a little bit, which is why I like to throw it out. But yeah, that's all I have for this problem. Let me know what you think. Yeah, is that it? Yeah, that's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Tomorrow's Saturday, or today is Saturday. Yeah, I'm really tired. My eyes are tired. Today's Saturday, so hope y'all are enjoying the contest and Google Code Jam and all those other stuff. And good luck, have fun, and yeah, stay good, stay healthy, and I will see y'all later. Bye bye.